Venus, often called Earth's sister planet, hides its surface beneath thick clouds. This view uses radar to penetrate that veil, mapping the planet's altitude. Look at a world dramatically different from our own. Venus rotates backwards compared to most planets, completing a day in about 243 Earth days. These images show a surface shaped by intense geological forces. These grayscale radar images the complex terrain. Notice the numerous linear features and circular structures, evidence of an active past. The Magellan spacecraft spent 10 years mapping nearly 98% of Venus. These false color maps show altitude, with reds and oranges representing lower areas and blues and purples the highlands. Fractured terrain is typical of Venus. The radar signals bounce off the surface, creating detailed images even through the dense atmosphere. This suggests a global resurfacing event, possibly due to massive volcanic activity. These plains show evidence of extensive lava flows. Volcanic features are abundant on Venus, around 1,600 major ones, more than any other planet. This imagery shows a potential volcanic caldera, a collapsed volcanic crater. The intense pressure on Venus is 90 times that of Earth, and its atmosphere is 96% carbon dioxide. This has created a runaway greenhouse effect, and the surface features show evidence of tectonic deformation. These radar maps show Tesserae, highly deformed and fractured terrain, but they likely represent ancient crustal material. Early observations from the Soviet Venera program landed 13 probes on Venus, but their short lifespans limited surface data. Radar mapping provided a much more comprehensive view of the planet. The warm colors in these radar images represent lower elevations. The rolling plains and fractured ridges suggest a high both volcanic and tectonic activity. The cloud cover obscures the surface, but radar allows us to see through it, a planet of extremes. This region displays a network of ridges and grooves, potentially formed by tectonic forces. The radar signal's strength varies, indicating differences in surface roughness. This elongated structure could be a massive lava flow, evidence of the planet's prolific volcanism far exceeding anything found on Earth. For decades, Venus remained hidden behind thick clouds, But radar technology allowed us to penetrate that veil, mapping 98% of its surface. This is what lies beneath. This long, winding feature is a rift valley, a geological scar stretching for thousands of kilometers, a sign of the planet's internal stresses. Maxwell Montes, the highest mountain, reaches 11 kilometers, comparable to Earth's Mount Everest. Maxwell Montes, the highest mountain on Venus, reaches 11 kilometers into the atmosphere, a towering peak in a land of extremes. These mountainous regions, mapped by radar, demonstrate Venusa's complex topography at a dynamic geological past. This fractured terrain, called Tesserae, is among the oldest known features on Venus, heavily deformed by ancient tectonic forces. Even through the clouds, radar imaging shows a fractured surface, a constant reminder of the extreme conditions on this planet, with an atmosphere 90 times Earth's pressure. These radar maps a region intensely fractured and deformed, likely shaped by both volcanic activity and tectonic stresses over millions of years. This three-dimensional view shows a Venusian highland, a region of elevated terrain. Radar images reveal volcanic regions on Venus, characterized by radial and concentric patterns, indicating numerous volcanic flows and domes. The planet has no moons or rings, unlike many of its solar system neighbors.